So one of the mysteries that was left over from this was that the magnetic field that we observed and that we took measurements of with Voyager 2, we observed no charged gas in the magnetic field trapped within the system.
Hey everybody, and welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. I came across this at the allegedly entertaining Daily Mail. Yes. Uranus isn't as weird as we thought, study finds. There's so many ways you could take that headline. Anyway, this should be very interesting. Uranus is often regarded as the weirdest planet in our solar system, but a new study suggests that the gas giant may not actually be as strange as we thought. Now, researchers from University College London, or UCL, say that the mysteries surrounding Uranus may have been the result of an unusually powerful solar storm that happened to occur just as a spacecraft visited the planet. Now, as usual, I'll leave the links to the main article below the video so you can pop in, check out the embedded links, go for a bit of a deeper dive if you want. Makes for an interesting read beyond the main article, believe me. Now, that spacecraft, NASA's Voyager 2, flew by Uranus back in 1986 and provided the first close glimpse of the planet. And since then, no spacecraft has been back. Now, almost everything we know about Uranus is based on Voyager 2's two-day flyby, said co-author Dr. William Dunn. Now, this new study shows that a lot of the planet's bizarre behavior can be explained by the scale of the space weather event that occurred during that visit. So basically it was a fluke. So when Voyager 2 went past it, it got the planet on a bad day with its weather. Interesting. Based on the findings, the researchers are calling for a return mission to Uranus to find out what it's really like when not in the midst of a solar storm. That's interesting, isn't it? There's Uranus. Uranus is often regarded as the weirdest planet in our solar system. Yes. Not actually be as strange as we thought. And there we go. This is researchers from the University College London say that the mystery surrounding Uranus may have been the result of an unusually powerful solar storm that happened to occur just as the spacecraft visited the planet. Well, nothing's changed much, has it? NASA has never been good with its timing. Interesting stuff. Yes, now in January of 1986, NASA's Voyager 2 became the first and so far only spacecraft to explore Uranus. Now, the mission snapped to the first images of Uranus, but also discovered several oddities. Uranus's radiation belts were found to be incredibly intense, while its magnetosphere was nearly empty of plasma. Now, we have a little video here that we'll check out. Very interesting on this, actually. And then we'll carry on the conversation when we come out the other side.
When NASA's Voyager 2 spacecraft flew past Uranus back in 1986, it was the first and still only close glimpse of this outer planet. And it had scientists baffled. It defied their understanding of how magnetic fields work. But 38 years later, after painstakingly going over the data, researchers say it can all be explained by a cosmic coincidence and that Uranus and its moons may be able to support life. To help us understand this, we are joined now by Jamie Jasinski, who is a space plasma physicist at NASA's Jet Propulsion Laboratory. Now, Jamie, before we get into this new research, can you tell us what we thought we understood about Uranus and why?
Yeah, sure. Thanks for having me on. So, like you said, most of what we know about Uranus is from the 1986 flyby with Voyager 2. And that flyby lasted about 5 days, and the data from that, where we observed the planet, the moons, and the magnetic field, is what has shaped the understanding. So one of the mysteries that was left over from this was that the magnetic field that we observed and that we took measurements of with Voyager 2, we observed no charged gas in the magnetic field trapped within the system. So that's really unexpected. We've been calling it a vacuum magnetosphere for the last 40 years. And that's unexpected because you would expect charged gas from the moons and the planet itself. So Saturn has a moon called Enceladus. It's this big ball of frozen water, but underneath that frozen crust, you have this subsurface liquid water ocean that's constantly releasing water into the system and filling that magnetic field. But we observed nothing with Voyager 2. And then the other sort of interesting mystery left over was the fact that you have this magnetic field that it's completely empty with this, it doesn't have any of this charged gas, but very close to the planet itself, we observe these very intense radiation belts. So Jupiter has the harshest radiation environment, these very intense radiation belts, and Uranus is the second one. So where are these particles coming from? If you have a completely empty system, where are these particles coming to feed these radiation belts and energizing them? So that was sort of the state of the picture the last 40 years since the flyby.
Yeah, so this outer planet, it was considered a bit odd. What has this new research uncovered?
So we went back and actually looked at the data to see what was going on during the flyby. And what we found was that during, just before the flyby started, activity from the sun essentially released a whole bunch of plasma, which smashed into the magnetic field of Uranus. And this absolutely squashed the magnetic field to about 20% of the size that it was before. And this can act to drive all that charged gas out of the system and then can feed those radiation belts. And that's really important because it kind of explains why we saw nothing from these moons. We thought that these moons may be sort of inert, inactive moons with just their frozen balls of water. But now we're thinking that actually this opens the door that they might have subsurface oceans that are liquid, subsurface liquid water oceans, similar to what we see at Jupiter with Europa. So Europa is a moon of Jupiter, and it's got more liquid water under its surface than all the oceans on Earth combined. And we didn't think that could be possible at Uranus after Voyager 2, but now this really opens up the door that you could potentially have all this water at these moons at Uranus.
And so what do we understand better now, and why is that important?
I mean, the search for habitability for possible life is obviously one of the key investigations for NASA and for just science generally. And obviously the slogan usually is follow the water. So now if these moons that we previously thought weren't really a place where you could find subsurface oceans, then probably weren't thinking that there could possibly be life. But if they are more similar to the sort of moons that we know at Jupiter, like Europa, then you could possibly have these large bodies of subsurface oceans at the Uranian moons.
NASA physicist Jamie Jasinski, thank you for speaking with us.
Thank you.
Well, that was very interesting, isn't it? It's good to get a little bit of background on these things. I find it fascinating. Solar storms, magnetic storms. Again, I'm not a scientist myself. I just love reading and learning and sharing science, space and tech news with everybody. You know, as I say, if there are any actual astrophysicists out there, planetary scientists, anyone like that, please feel free to comment. We'd love to hear from you. Yes, put your 2 cents worth in because it'll be great. Now, this meant that there was no apparent source of charged particles to feed those intense belts. Now, in their new study, the researchers found that a hurricane of extreme solar weather could explain the result. Now, the hurricane likely squashed Uranus's magnetosphere, God, I hate it when that happens, pushing plasma out of it, I'm sure it did, and intensifying radiation belts by feeding electrons into them. And Uranus itself wasn't the only celestial object affected by the event. Oh, please, do tell me more. Uranus's 5 moons were long assumed to be dead worlds because of the planet's nearly empty magnetosphere. There you go. And it's got NASA's Voyager 2 snapped the first images of Uranus, but also discovered several oddities. Uranus's radiation belts were found to be incredibly intense, while its magnetosphere was nearly empty of plasma. This meant there was no apparent source of charged particles to feed those belts. God, it's hard to believe that's, 35 years ago? Or 30, sorry, Mum needs a refund from the bloody Catholic school for school fees. I can't add up. 38 years ago. Incredible. Now, but the new findings suggest that the moons could be geologically active after all and may even have oceans. Now, if Voyager 2 had arrived just a few days earlier, it would have observed a completely different magnetosphere at Uranus, said Dr. Jamie Jasinski of NASA's Jet Propulsion Laboratory, or JPL, who led the study. Now, the spacecraft saw Uranus in conditions that only occur about 4% of the time. Oh boy, talk about bad timing. Based on the findings, the researchers are calling for a new and carefully considered mission to Uranus. Now, we now know even less than we thought about what a typical day in the Uranian system might look like. and are even more in need of a second spacecraft to visit to truly understand this mysterious icy world, Dr. Dunn said. Note, don't make it a Boeing spacecraft. Now, a big piece of evidence against there being oceans on Uranus's moons was the lack of detection of any water-related particles around the planet. Voyager 2 didn't find water ions, but now we can explain that. The solar storm basically would have blown all the material away. Yes, the design of the upcoming NASA flagship mission to Uranus should be carefully considered in the context of these findings. Now, for instance, we might want instruments that could detect nudges to the magnetic field from a moon's salty ocean, and instruments that could measure all the particles in the system to test whether we find water or other important materials from the moons. Absolutely love it. I think, yes, definitely need to go back there. It's, you know, isn't it interesting how you can just one bad run past can completely, you know, change what is 96%. Totally different, you know. So again, I find it very, very interesting, and this is the reason why we need more study of Uranus, because I've done videos on, you know, the moon, you know, the moon like Ariel and things like that could have oceans. Check some of the videos out on the channel here, because it's absolutely fantastic, some of the things we're discovering lately. And again, I'm not a scientist at all. I'm just an old nerd who absolutely loves science, space, and tech news and sharing it with everybody. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. Greatly appreciate it. If you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
Fake off!
5,